Okay, so this talks about Electrum Personal Server, and I'll tell you a bit about why I think it's important, and then a bit about how it works and that kind of stuff. So yeah, so, right. So Electrum Personal Server. So I'll start not there. I'll start a bit with Bitcoin itself. So Bitcoin is obviously a digital currency, and we use it through wallet software. And the thing that's sometimes missed that a lot of people should know is the entire security model relies on most of the economy using full node wallets. And that means, what's a full node? Full node means that all the rules of Bitcoin have been checked. So they check that, for example, no Bitcoins have been created out of nothing, or nobody spent a coin without knowing the private key.
No double inputs.
Yes, exactly that kind of thing. And all kind of DOS variables, so not too much data came all at once, and that kind of thing. You can use an analogy that if Bitcoin is digital gold, then a full node wallet is your own personal goldsmith who checks that the gold is actually real. Or if Bitcoin is digital cash, then using a full node wallet is a bit like checking the banknotes are real. So checking the hologram and the watermark and microlettering and all those other security features. So aside from that, also full nodes are good for privacy, because the way they work is they download the entire blockchain on your hard drive or whatever, and check which of the, or locally check which, if you have any transactions coming to you. And that would mean that if anyone is watching your connection from the outside, all they see is you downloading blocks, and they don't see which transactions or addresses you're interested in. And other kinds of wallets, like lightweight wallets, which are not full nodes, they don't do this. So generally, if someone's watching the connection of somebody who uses a lightweight wallet, like on their smartphone or something, they can normally see how much money they have and what transactions they've made and who they've sent money to, and that kind of thing. So full nodes are great for this security, that the whole of Bitcoin relies on them, and privacy, that you don't tell any spy what you're interested in. Now, this was quite like an academic thing. I said, this could happen, but this actually did happen, that there was, between 2015 and 2017, there was this scalability conflict. And that was kind of like a drama on the internet of people, one group of people wanting one thing and the other group of people wanting another thing. And that was directly related to the thing I just talked about. That one group of people wanted to increase the block size, which would mean that full nodes would be more expensive to run. And the other group, opposing them in this drama, essentially were against that, and they said full nodes should always be easy to run because you can check the rules and be private and all that stuff. And that lasted for a long, 2 years, and there was lots of drama and all kinds of things happened. But that culminated in this UASF, which means user activated soft fork, and that made it, it's a long thing. You can read about it, but there was an update to Bitcoin called segregated witness, and there was a drama of whether that should be added or not. And that was in the end added, and the fact that full nodes were easy to run, that most people could run them, was essential for segregated witness actually being added. So that then happened, and that finished on 1st of August 2017, and that kind of set the stage for the bull run, essentially, when Bitcoin got in the news again and all that kind of thing. So there's a great blog post about all this stuff called The 3 Economic Eras of Bitcoin by Rusty Russell. And that kind of goes a little bit through history and summarizes. And it makes a prediction that eventually there'll be another similar drama, which instead of the block size will be about the supply limit. So Bitcoin has a maximum supply limit of 21 million coins. And there'll probably be another drama, this blog post predicts, about people saying, oh, we should add inflation and all that kind of stuff. So those events and that kind of thing is what got me thinking about full nodes and making full nodes easier to run and more accessible and that kind of thing. So in kind of the status quo before this, lots of people kept their coins on hardware wallets, and they were mostly, you had a hardware wallet, and most people generally connected them to the web wallet of the manufacturer who made the hardware wallet. So that would mean they were trusting this web wallet to tell them what was the true Bitcoin, to check all the rules for them, which would mean if the hardware wallet manufacturer swapped their web wallet onto something else, they could add inflation or those other kinds of things, or steal someone's money. And not to mention, they could also spy on the users of hardware wallets because they knew what all their addresses were. So Electrum, the reason Electrum comes into this is Electrum can be integrated with hardware wallets. It has a lot of nice features like multi-signature wallets and hardware wallet integration. and you can sign offline and all that kind of stuff. It's quite a nice wallet. It's something I quite like. But the problem is it's a lightweight wallet, so it's not a full node in the sense that by default, they're Electrum servers, and they contain, it's essentially a big server. It uses quite a lot of resources, and it has every single address that was ever used on the entire Bitcoin blockchain in a big database, and they're linked to the transactions on that address. So the way Electrum wallets work is they figure out the addresses of the user, and they connect to a server and ask it, please tell me these transactions. And the server then looks up in its database and then finds the transaction and sends them to the user. So that has the same problem as other lightweight wallets, is that the server can spy on the address, spy on the user, because they know exactly which addresses are theirs and which transactions. And they could lie to them. They could say, this transaction is valid, but it actually prints money or steals a Bitcoin from someone else. And the thing that makes it difficult you could fix this by having everyone have their own Electrum server on their own computer and then connect their Electrum wallet to that. But because Electrum servers, they use a lot of resources, there's this database I mentioned out, and you can't enable pruning, so you have to have the entire blockchain on disk, and you have to have a separate transaction index, which is also another few dozens of gigabytes. So that's not very conducive to having it be decentralized, because they need a lot of time to set this up. You need to build this database, and you need all the hard disk space. So I was thinking about that, and then into that comes Electrum Personal Server. And essentially what that is you have Electrum connect to Bitcoin Core's internal wallet. And you essentially have a small gateway script. And on the one side, it speaks the Electrum server protocol. And on the other side, it speaks Bitcoin Core's wallet protocol. So that would allow you to use Bitcoin Core's resource-saving features. You can turn on pruning, which means you don't have to store the entire blockchain. And you also don't need all these other databases. You don't need the transaction index or that address index or anything like that. And you could turn on resource-saving features to reduce the bandwidth that Bitcoin Core uses, or you could use, for example, there's an idea where you have a satellite and it connects to a satellite dish, rather. It connects to a satellite in space, and that can send you blocks, and you can use all kind of tricks like that, or you could connect through Tor or anything you come up with. But then once you have your node, your full node, you can just connect your Electrum wallet to it and have the full privacy and security that it provides. But the trade-off is that there's no instant on. So in Electrum's promotional material, a good aspect of it is you can just download it, double-click, and it turns on the application, and you can just use it. There's no waiting too much for anything to happen, for too many things to be downloaded or anything like that. And that's what it means by instant on, and you can't have that with Electrum Personal Server, because you have to configure which is your wallet that's being used. Now, the reason Electrum Personal Server uses a bit less resources is that it doesn't track every possible address that's ever been on the blockchain. It only tracks your addresses. And that means you have to tell it what your addresses are in a little configuration file. So that's the trade-off there. So I'll tell you a little bit how it works internally, that users configure their own master public keys. And then the Electrum Personal Server calculates the addresses from that and watches what happens to them. And then it just generates a Python dictionary with all the addresses and transactions. And if the Electrum wallet comes in and it requests what happens to these addresses, the server just looks in this dictionary and sends those transactions to the wallet. It's actually quite simple. It's a small. It didn't take me a very long time to write this, because it's really quite simple. It's more about the hard part of it was figuring out that you could do this, and then writing it's not that difficult. And there's some other details like Merkle proofs, that the format used by Core to have Merkle proofs is different from the format that Electrum uses. And then there's a bit of details of converting from one format to another. Yeah. And
why is the Electrum server database not printable?
Because the Electrum server, so they're made so that any possible wallet could connect to them. They're generally meant to be not behind a firewall, but they almost get added to, a lot of them get added to a default list that all Electrum wallets can connect to. They connect to many different servers. So it means anyone could just make a wallet, and they'd have to go to a server, and the server has to be able to tell them what the transactions are. and then the server has to know every possible transaction, like mapping between address and transaction. Yeah, so you could call them like Electrum public servers instead of personal servers or something like that. So these are some other ideas I've been thinking up of what to do next. So Tor broadcasting, that has this problem that if you broadcast an unconfirmed transaction, that leaks your IP address a little bit. So what there is there's some companies that try to spy on people in Bitcoin and try and de-anonymize their transactions. One thing they can do is they can try and connect to every single node on the Bitcoin network. And then when an unconfirmed transaction spreads through the network, they can watch this transaction spreading. So if it's trying like broadcast over there somewhere, they can see it spread over there slowly, and eventually it will move through the entire network to over here. And they could learn some of the IP address information of that. So a way to avoid this would be Tor broadcasting, which would just be when you want to broadcast a transaction, you connect through Tor, the onion router, which hides your IP address, and connect to another random node on the Bitcoin network, and then broadcast your transaction to that, and then disconnect. And that would have an advantage that you could download the blockchain, which is about 200 gigabytes, through ClearNet, through your normal ISP or whatever it might be, which is quite fast and works and that kind of thing. And that doesn't have any privacy trade-offs, so it only reveals that you're actually using Bitcoin. It doesn't reveal which addresses you are. So you can use the fast ClearNet for downloading blocks, and then the slow Tor for broadcasting transactions. And that would work quite well for Electrum Personal Server, because you could make it that on the Electrum GUI, when you click the button broadcast, that will send a message to the server. And right now the server just broadcasts through the node, but you could change that to make it broadcast through Tor instead. And that'd be quite easy and be quite user-friendly, because they just click broadcast and then it's private. Yeah, so next thing, I've been slightly misleading in this talk. I've said Electrum Personal Server is compatible with pruning. It's actually not. There's one final thing which isn't, which is the Electrum wallet asks for Merkle proofs. And the way you get that through core is there's an RPC call called getTXOutProof. And that looks at the actual blocks on disk. And it means if you've enabled pruning, which means you've deleted those blocks, then this RPC call will fail. So you can prune, but you should only prune in the last, leave the last year or so of blocks, or however old your wallet is. And that would, so if this wouldn't work, then your Electrum wallet would show not verified, which means it would tell the user that it's not trusted, because it hasn't been mined into a block by a miner. So a solution to this I've been thinking of that I'll probably do is to make Core's wallet also keep track of Merkle proofs to transactions. So every time if a transaction arrives that's to do with the wallet in Core, it will also save the Merkle proof. Today it saves the transaction hex and which block it's mined in and all that stuff, and you should just also add Merkle proof. And that would be, it's about maybe 500 bytes or so. It depends on how many things are in the block. But it used to be in Core before 0.12, before 0.12, but you couldn't really access it, and then it was removed then. And so I'll have to have discussions of maybe there'll be a flag you can disable it if you want to save space or something.
Sorry, I got confused. What was removed?
So there was a feature that in Core's wallet, it used to keep track of these Merkle proofs. They'd actually be in the wallet file. In the wallet file.
So the getTXOutProof has always been around?
It's always been around as far as I know, but it looks at the actual block files.
Yeah, it looks at block, not the wallets.
Yeah.
Green address, I think green address or the other one, but also uses Merkle proofs. I think it's a lightweight wallet in that it just uses the backend to show your transactions, but then you can tell it to do extra verification, and you'll slowly see these blue ticks appear next to your transactions as it's getting all the Merkle proofs.
As it gets the Merkle proofs.
Yeah.
Yeah, lots of lightweight wallets do that because they do that it's a proof that a transaction has actually been mined inside a block, which means that a proof of work has been done, so they've spent at least some money for the mining. But it doesn't prove that any of the other rules have been followed. So it would mean lightweight wallets, they essentially trust the miners. So miners could steal someone's Bitcoin or print infinite money or anything like that. Yeah, so Green Addressed and Electrum as well, and probably loads of other wallets. And it has some other uses as well. So one is you could have, or you could ask me about later, but one is you could have a time-locked Bitcoin. So you send it to a OP check lock time verify. And this could be a pruning-compatible proof that some Bitcoins have been locked up. Because if you show someone the transaction and the Merkle proof and the block header, that's enough to prove that these Bitcoins have been locked up for whatever, a year or anything. And that can be useful for protocols where you want to make it more expensive to do a denial of service. So like in some coin swap things or...
But if you were transferring such a proof,
yeah.
you lose the gain. You currently have an EPS, which is that it's not, you do know that all the rules of Bitcoin follow,
yeah.
it's your node.
Yeah.
You can transfer the proof.
No, you can transfer the proof. It's useful if the other person has pruning.
Right.
The other person could also be a full node, and they've checked all the rules are followed,
Yes, of course, you're
but they delete all the blocks with pruning, and they still have all the block headers. So you can say, oh, here's a Merkle proof that goes to block headers, and therefore it exists.
And those headers are still obtained using full node.
Yeah, and we know they're true, and they're only 80 bytes each, so there's like 80 megabytes for all of them or something. Yeah, something else. So this is actually George's suggestion, which is I've been calling it the no history sync. So the new version of Bitcoin Core 0.17, it has a new RPC call called scan tx out set. And what that does is you give it a lot of Bitcoin addresses, and it will look through the UTXO set, which is a database of every unspent coin, and see which, it will return to you the UTXOs which live on these addresses. And that would mean you don't have to rescan like you do on Electrum Personal Server today. And so that could be kind of fixing the thing of a little bit of how Electrum Personal Server is an instant on. You don't have to rescan. But then on the trade-off is you don't get your history. So you can only see what's in your wallet at this moment, and you can't tell anything else that happened, any fully spent coins or transactions.
Unless you patch Electrum to just store the history.
Yeah, but then it needs to get the history from somewhere. Generally, it gets it from a server. And if you could like get from a public server and then connect to your server, but then it will delete the history it already has. So I'd envision this could be quite useful if someone has 10 or 20 like those seed phrases backups, and they want to see, are these empty or do I actually have money on them? And then they import them one by one, and you could use this to see, oh, I have this much money, or I don't have any money, I can throw them away. Yeah, but it's not entirely instant on because you still need a full node that's fully synced. But at least you don't need to rescan. And then there's a few other ideas. So right now, Electrum Personal Server only accepts one socket at a time, which means if you have a smartphone Electrum wallet and a desktop Electrum wallet, they can't connect at the same time, which is useful, especially for things like multi-signature. You can like have one key on a desktop and one key on your smartphone, and they have to both be hacked to steal your money. And that just has to be recoded. You can use select and other stuff. Then there's this idea of using Bitcoin Core as a backend for a lightweight wallet. You could use it for stuff that isn't Electrum. So I've been calling that BIP37 Personal Server. And that would be a similar kind of thing, that you tell these wallets what all your addresses are, and they import it into Core, and it tells you what the transactions are. And that's probably most interesting for BISC, which is a decentralized exchange. And the reason is that BISC uses BIP37, and the only way you can connect it to your own full node is if you haven't got pruning enabled. So you have to have 200 gigabytes of blocks, or however much it is now. And then the third thing is Lightning. That's the next big thing in Bitcoin. Electrum will be adding it, probably all loads of other wallets. And I'd like Electrum Personal Server to work on that as well. Probably what will happen there is they'll use Neutrino, the BIP147, I think is the name, because right now a problem with Electrum servers is they could lie by omission. If a wallet asks, has there been a transaction which closes a channel invalidly, the server can lie and say there was no transaction, and there's no way to prove that. But with Neutrino, you can prove that there has been a lie by omission, so they'll probably do something like that, and then it'll be added. And yeah, that's if anyone has any questions, I'd be happy to answer them.
How long have you been working on this?
About 5 months. It's quite short, it's quite a simple project, and you don't need to do that much coding, especially compared to a lot of other stuff that people do in Bitcoin. It's quite short. It's really nothing almost. It's made of about 5 Python files. So it doesn't take very long to do.
And have other people tried something similar?
Not to my knowledge. Nothing. No, I don't know. Some other people have helped me code this, like added patches and that kind of thing, pull requests.
What's the benefit of connecting to the Bitcoin Core wallet? You want to avoid writing consensus code and...
Yeah, that as well. But yeah, so you don't have to duplicate work. The Bitcoin Core already exists, and you could connect to it, and then you get the benefits of security and privacy from that. That's the way I think of it.
Can I ask about the configuration of the core node? Like, so what should it and should it not have? So obviously it doesn't need to be like compiled with the GUI.
That's right.
There's the wallet. Obviously you need the wallet. And I think, isn't there a new feature where you can have a wallet where it's like no signing? Does anyone know what I'm talking about?
Yeah, so watch-only wallet.
Not just watching only one, but there's a new feature that's like actually configure it so that it absolutely refuses to use private keys under any circumstances.
Yeah.
Yeah.
There's like a no private key thing.
No private key, that's it, yeah. Is
that could be useful as well because it's only watch-only.
Mm-hmm.
So all the private keys are kept on Electrum, and they could be on a hardware wallet as well. So it's only for looking at received transactions and not so much about sending them or signing them.
Do you need TXNX or do you not?
No.
No, because it uses the Bitcoin Core wallet.
Oh,
Yeah,
So
and that's compatible with...
But then you need a rescan. So without the
Yeah.
information, you need a rescan.
Yeah, exactly.
And if you prune too far, like if you don't use the wallet, then you might have a problem.
And have you been in contact with the Electrum devs and maybe you could streamline the protocol?
I talked to them a bit on IRC, like not
Maybe
really.
because it was designed for this. That they made the client and they make the server.
Yeah.
So now you are a third-party client. Maybe there's some.
There could be. There's been some like bug fixes and stuff. So there was a time when Electrum released a new version and it wasn't compatible with Electrum Personal Server through like my fault, basically. And then there were some crashes, and then they told me about that. And then there's some other things. So for example, Electrum Wallet always chooses the fastest possible server, but a lot of people, or not the fastest possible, but like it has a very low timeout. And if the server doesn't reply within 5 seconds or something, it disconnects and finds a new one. But a lot of people are running Electrum Personal Server on things like Raspberry Pis, or you connected them through a Tor hidden service, so it's quite slow and the hardware is quite slow. And then Electrum sometimes says, we don't want this, it's too slow, and anything like that. And then there'll probably be something there we can fix and make Electrum tolerate that stuff. Apart from that, I can't think of any other times I don't know, I've been in their IRC channel for years, so I'm not new to them, I think.
How would you envisage like an ordinary user? Obviously, let's say a sort of medium user.
Yeah.
I mean, are they going to put their core node? Would it be okay? Do you think put the core node on the VPS? Some remote machine doesn't actually have to be like their laptop or something, right? Because there's no. Well, it's kind of a grey area, isn't it? If you put a node on a VPS which is watch only, you've taken away any risk of security of your coins, but maybe there's a privacy risk.
And they could lie to you as well as spy on you. I think it depends on the user's threat model. So if people are using Bitcoin in Venezuela, they could have a VPS which is just outside Venezuela, and that would work perfectly fine for them. But then if someone's using Bitcoin in maybe somewhere Bitcoin is totally banned, like North Korea or something like that, then they might want to have a core node which is only like on a little Raspberry Pi in their room and no one knows about it, and maybe it connects through Tor. So it probably depends on all those kinds of details. One thing,
Then someone finds it.
then you're in trouble as well.
Elsewhere, you're not in trouble.
Yeah, you're not in trouble.
You can imagine a Bitcoin Core node that uses these new filters only, or
What,
like
committed Bloom filters?
the
you mean them?
not the Bloom filters, but the neutrino protocol.
Right, yeah.
So then it would use less bandwidth than a normal full node. You'd have slightly less security, but otherwise it would work the same.
Yeah.
That could be a trade-off.
Or the Blockstream satellite. It's quite fun if you can.
Yeah,
stuff like
satellites
this.
don't attract attention at
Yeah,
all.
I know.
And you can look at it and see where it's pointed.
Yeah. Yeah, that's right. It depends
You've got
on.
to sync at some point. You're not going to sync
Yeah.
with a satellite.
You could do a thing where you buy a hard drive.
Days, I think they repeat the last 48 hours.
Oh, if you miss one. You could do a thing where you buy a hard drive which has all the blocks on them. Someone sends it to you in the post. And then for the rest of them, you have the
Just a hard
satellite.
drive with a tiny SD card.
Yeah.
You can fit it.
Put it behind the postage stamp or something
Put
like
it in
that.
a cat. Ship it down.
Yeah, you got it. You can be all kinds of creative things depending on your threat model. There is something for making it a bit easier, which I should do or learn how to do, is use Docker. So that's apparently a solution where you can essentially run it's Docker for any project, and you just run a script and it will install this project for you. So Electrum Personal Server or anything else, Apache, or anything you can think of.
The thing that they replaced it, like this Docker image thing.
BTC server. BTC Pay server. Yes. Yeah, exactly. They have one of that as well, and it's really easy to use. You just download and run this, and it works.
Do you have it all?
Sorry?
Yes, do you have it all?
No, I haven't made that. I haven't implemented that yet. It'll be good when I do.
Does it work with APS? Does it work with Trezor?
Yeah.
Just change the address. Trezor the spot to Electrum.
So what you would do is connect Trezor to your Electrum wallet, and then connect Electrum wallet to Electrum Personal Server. So any hardware wallet which works on Electrum will work with Electrum Personal Server. And they have Treasure, Ledger, Keep Key, and a fourth one I've forgotten.
But if I don't have the core wallet, plus Trezor, so I need the Electrum wallet as well.
So if you don't have a core node,
So I have a core node and
Yeah.
a hardware wallet. Trezor.
Yeah.
That's only the only two I have. So I need.
okay. Then there is another thing which I think Sora is going to talk about now, which is connecting them together directly. That would be a solution as well. But if you want to go by Electrum, then you'd use this.
This is easier, I can guarantee you, but I'll show you the other approach.
Yeah.
So connects them directly without the personal server tool.
Yeah, the solution I'll show does not need Electrum, works directly, but it's extremely manual.
You talked a bit about why you chose Electrum. Are there any other candidates that it could work, like a similar configuration could work?
I'm not aware of any other lightweight wallets that connect to hardware wallets, or anything which has there's Green Address, and that has it's not a general multi-signature wallet, but it has a thing where you have one key, and the Green Address server has another key, and then together they have like a two-factor authentication. And they already have a feature where you can connect to your own full node, and that could be that's via BIP37, like BIP37 plus some other stuff. And that could be, and the thing I talked about, BIP37 Personal Server, you could use that there. Because the same for BIP37, it's not compatible with pruning. You have to have all the blocks on your disk.
Are Samurai's similar situation?
Yeah.
Does anyone know? I don't use it.
I think they also use BIP37 plus. They like check some server if the block hash is, so you haven't gone off on some like inflationary chain. Yeah, and I think you can connect to your own full node. Yeah.
And what's the feature work? What still needs to be done?
That would be that stuff. So there's the Tor broadcasting, and then the wallet Merkle trees, making it work with Lightning when Electrum does that, and what else did I say? Oh yeah, making it work so you can connect two wallets at once, and that kind of thing. And then, oh yeah, this no history sync. And then Docker.
There wouldn't be any more challenges with Lightning. You're just dealing with the funding
Yeah.
transaction.
Yeah, you just have to fix the problem that the server can lie by omission. They could say, oh, there was no invalid close, and then they steal your money. Yeah.
Any other questions? Okay, well thanks a lot.
All right, thanks.